Hello everyone, welcome to an algebra tutorial video about properties of exponents. In this video we're going to tackle negative exponents and answering the question, what does a negative number as an exponent mean? Negative numbers are often kind of confusing in and of themselves, but when we throw them into exponents, then it gets even more confusing and just hard to wrap your head around. So hopefully by the end of this video it's going to make a really good sense to you about what an exponent is. All right, we're going to start off by looking at a number pattern. Let's take the number 2. My pattern is I'm going to multiply to get bigger by 2. So I'm going to take 2. Let's multiply that by 2. And the next number would be 4. Let's take that 4 and multiply it by 2. And we get 8. 4 times 2 is 8. Now let's go one more. The pattern, multiply by 2. And we get 16. So it's not a difficult number pattern, right? Just doubling up every time. 2, 4, 8, 16. The next would be 32, then 64, and so on. I can keep going. We can put a little dot, dot, dot. I can keep going bigger that way. Now let's kind of rethink this number pattern in terms of 2's, how many 2's I have. So this first one is just 1 2 by itself. So one way to think about the number 2 is it's just 2. Whoops, I want to switch colors here. 2 to the first power. Well then if I take that 1 2 and multiply it by another 2, I end up with 4, which is 2 2's, or 2 to the second power. Multiply it by a third 2 and we have 8, which is 2 to the third power. Multiply that 8 by another 2 and I end up with 16, which is 2 to the fourth power. And there is our exponents. It's repeated multiplication, and the exponent just tells me how many 2's are multiplied at that point. And it can keep going on and on. You know, next one, 32 would be 2 to the 5th, 64 would be 2 to the 6th, and so on. Okay, but now let's think about this pattern in reverse. Say if I'm starting with 16 and I want to go back to the left, what do I do to 16 to do the opposite pattern, to get it back down to 8? Well, instead of multiplying by 2, the opposite is to divide by 2. So 16 divided by 2 gives me 8, and it goes from 2 to the 4th to 2 to the 3rd. If I divide by another 2, 8 divided by 2 gives me back to 4. So it goes from 2 to the 3rd to 2 to the 2nd. And if I divide by another 2, 4 divided by 2 gives me 2. Now, if the pattern can go on indefinitely to the right, what if I keep decreasing this pattern going to the left? What would be the next number in this pattern? Well, I would divide by 2, and 2 divided by 2 gets me to 1. Well, if I'm continuing this pattern, 2 to the 4th, to 2 to the 3rd, to 2 to the 2nd, to 2 to the 1st, it makes sense then that 1 would have to be 2 to the 0 power. So again, it's our 0 exponent property. Anything to the 0 power is 1. So we can see that kind of makes sense too, right? It fits with what we have going on. It fits with our pattern. And I could even go back the other way. I could take that 1 and multiply it by 2 to get back to 2, to what I started with. So I can always get right back. But we're moving on. So it kind of makes sense. 2 to the 0 power is 1. 2 to the first power, there's 1, 2. So I'm getting 1, 2 right there, and so on. What if I keep going to the left? What if I divide by another 2? Well, I'm taking the number 1, and I'm dividing it by 2 again, so I should end up with 1/2. But what do I put for an exponent here? What makes sense then? If I'm following the pattern in red, 4, 3, 2, 1, 0, well, it makes sense to say this is 2, to the negative 1. I'm going in the opposite direction. Let's keep filling this pattern out again. We're going to divide by another 2. Well, 1/2 divided by 2 is going to be 1/4, which is 2 to the negative 2 power. Let's do one more. Divide by 2 again. 1/4 divided by 2 is going to be 1/8. And following -1, -2, 1/8 would be 2 to the negative 3rd. And I can keep going on with this pattern as far as I want to the left. Now what do we see? If a positive exponent is repeated multiplication, let me write that out here. So positive exponent, we've looked at that in expanded form, it's repeated multiplication. Let me finish writing this out. A negative exponent, negative is just opposite, right? Negative exponent then is repeated division. That's what we see happening with the green. As I repeatedly divide by 2 over and over again, it moves me in the opposite direction. I'm not getting bigger for my exponents, I'm now getting negative. I'm getting in the negative direction, I'm getting smaller exponents. And here is our definition of a negative exponent. Any number or letter or variable or expression, anything to the negative m power, and just m is any variable, expression, number, anything, but it's anything to the negative power, negative exponent, I can rewrite as 1, because 1 is kind of my middle placeholder, right? I either multiply 1 or I divide 1, but it's 1, instead of multiplying numbers, it's 1 divided by a whole bunch of b's. So you can see there, 8 is 2 to the 3rd, but instead of 2 to the positive 3rd being 8, 2 times 2 times 2, 2 to the negative 3rd is 1 divided by 2 times 2 times 2, 1 divided by 8. So you can kind of see that flip-flopping opposite pattern happening. Instead of multiplying 2 times 2 times 2, we have division. Divided by 2, divided by 2, divided by 2. Okay, hopefully that is a great explanation about what a negative number is. We'll do some examples about working with expressions that have negative numbers, but at least this gives you a conceptual understanding of where negative numbers come from, why we have negative numbers, and how they fit with our ideas of repeated multiplication or repeated division.